Welcome to our comprehensive guide on Spring Cloud Stream. In this video, we'll explore the essential concepts, architecture, and practical usage of this powerful framework for building message-driven microservice applications. Spring Cloud Stream leverages Spring Boot and Spring integration to simplify connectivity with various message brokers, making it easier to develop scalable, event-driven systems. Whether you're new to microservices or looking to deepen your understanding of distributed messaging, this guide will walk you through the core features, configuration options, and real-world examples. Let's dive in and discover how Spring Cloud Stream can transform your application development process. Core of Spring Cloud Stream focuses on how you can create and run stream applications. This section delves into the foundational elements, such as the application model, binder abstraction, persistent publish-subscribe support, consumer groups, and partitioning. By understanding these core concepts, you'll be equipped to design robust, scalable microservices that communicate efficiently through messaging systems. The core also introduces the programming model and configuration options, setting the stage for hands-on development. Spring Cloud Stream is a framework designed for building message-driven microservice applications. It leverages Spring Boot to create standalone, production-ready applications and uses Spring integration for connectivity to message brokers. The framework introduces key concepts like persistent publish-subscribe semantics, consumer groups, and partitions, making it easier to build scalable, event-driven systems. With simple annotations like @enable binding and @stream-listener, developers can quickly connect their applications to message brokers and process events efficiently. Illustrate how easy it is to get started, let's look at a simple sync application. By adding the @enable binding annotation to your application, you can immediately connect to a message broker. Using @stream-listener, you can define methods that receive and process events. For example, a vote recording sync application can listen for incoming votes and record them using a voting service. This approach abstracts away the complexity of broker integration, letting you focus on your business logic. Spring Cloud Stream uses interfaces to declare input and output channels. For example, the sync interface defines an input channel, while source and processor interfaces define output and both input-output channels respectively. The @input and @output annotations identify these channels, and you can customize their names as needed. Spring Cloud Stream automatically generates implementations for these interfaces, making it easy to inject and use them within your application. Spring Cloud Stream introduces several abstractions and primitives to simplify message-driven microservice development. These include the application model, binder abstraction, persistent publish-subscribe support, consumer groups, and partitioning. Each concept plays a vital role in enabling scalable, loosely coupled communication between microservices. Understanding these building blocks is key to designing effective event-driven architecture. The heart of Spring Cloud Stream is a middleware-neutral core. Applications communicate with the outside world through input and output channels, which are injected by the framework. These channels connect to external brokers via binder implementations, allowing for flexibility and portability. Applications can be run in standalone mode for testing or packaged as executable fat jars for production deployment, leveraging standard Spring Boot tooling. Binder abstraction is a key feature of Spring Cloud Stream. It provides implementations for popular brokers like Kafka and RabbitMQ, as well as a test support binder for testing scenarios. The binder abstraction allows applications to dynamically choose destinations and binders at runtime, using external configuration properties. This flexibility enables seamless switching between different messaging systems without changing application code. Spring Cloud Stream uses a persistent publish-subscribe model for inter-application communication. Data is broadcast through shared topics, allowing multiple applications to process the same data independently. This reduces complexity for both producers and consumers and enables new applications to be added without disrupting existing flows. The publish-subscribe model is central to building scalable, decoupled microservice architecture. Consumer groups allow multiple instances of an application to share the workload, with each instance processing a subset of messages. Spring Cloud Stream models this using group names, ensuring that only one instance in a group handles each message. Group subscriptions are durable, meaning messages are retained even if all consumers are temporarily offline. This ensures reliability and scalability in distributed systems. Partitioning is crucial for stateful processing and scalability. Spring Cloud Stream enables partition data processing by allowing producers to send data to specific partitions and consumers to process data from assigned partitions. This ensures that related data is always processed by the same application instance, which is essential for consistency and performance in distributed systems. Spring Cloud Stream's programming model is annotation-driven, making it easy to declare and bind channels. Yet enable binding annotation triggers the configuration of the messaging infrastructure, while @input and @output define the channels. This model supports multiple binding interfaces, allowing for flexible and modular application design. Developers can focus on business logic while the framework handles the messaging details. You can customize channel names using the @input and @output annotations. This allows you to define meaningful names that reflect your application's domain, improving readability and maintainability. Customized channel names are especially useful when integrating with external systems or when multiple channels are involved in complex workflows. Spring Cloud Stream provides three predefined interfaces: source, sync, and processor. The source interface is for applications with a single outbound channel, sync for a single inbound channel, and processor for both. These interfaces cover the most common messaging patterns and can be extended or customized as needed for more complex scenarios. Bound channels can be accessed by injecting the generated beans or directly injecting the channels themselves. This flexibility allows you to choose the most convenient approach for your application. Whether you prefer working with interfaces or direct channel injection, Spring Cloud Stream makes it easy to send and receive messages. Spring Cloud Stream supports both Spring integration annotations and its own @Stream Listener annotation for message handling. The @Stream Listener annotation simplifies inbound message processing, especially when dealing with content type management and type coercion. This makes it easier to write clean, maintainable code for producing and consuming messages. Spring Cloud Stream provides robust error handling by supporting error channels. Errors encountered during message processing can be published to specific destinations, allowing for centralized error management and monitoring. This feature enhances the reliability and observability of your messaging applications, making it easier to detect and respond to issues. @Stream Listener annotation in Spring Cloud Stream provides automatic content type handling. When a message arrives with a specific content type, the framework's message converter mechanism automatically converts the payload to the required type. This reduces boilerplate code and ensures that your application can handle various data formats seamlessly. Since version 1.2, Spring Cloud Stream supports dispatching messages to multiple @Stream Listener methods based on conditions. Using SBL expressions, you can route messages to different handlers depending on message headers or payload content. This feature enables sophisticated message routing and processing logic within your applications. Spring Cloud Stream offers support for reactive programming using Reactor and Rx Java. With reactive APIs, you can handle continuous data flows declaratively, using operators to transform inbound and outbound streams. This approach is ideal for high-throughput, event-driven applications that require non-blocking, asynchronous processing. Reactor-based handlers in Spring Cloud Stream use Flux and Flux sender types for processing streams of data. You can annotate method arguments with @input and @output to connect to specific channels. This model supports both single and multiple output scenarios, providing flexibility for complex data processing pipelines. In addition to Reactor, Spring Cloud Stream supports Rx Java 1x for reactive programming. Rx Java handlers use observable and observable sender types, following similar patterns as Reactor-based handlers. This allows developers to choose their preferred reactive library for building responsive, scalable applications. Spring Cloud Stream Stream Emitter annotation enables the creation of reactive sources. Methods annotated with @Stream Emitter can emit data to output channels using Flux or Flux sender. This feature is useful for generating continuous data streams, such as time-based events or sensor data, and publishing them to message brokers. Spring Cloud Stream supports aggregation, allowing you to connect multiple applications directly without routing messages through a broker. Using the aggregate application builder, you can chain sources, processors, and sinks into a single, efficient pipeline. This reduces latency and resource usage, making it ideal for tightly coupled processing stages. When aggregating applications, you can configure properties for each component using namespaces. This allows for fine-grained control over individual application settings within the aggregate. Properties can be passed via command line arguments or environment variables, ensuring flexibility and ease of deployment. Binder abstraction connects your application's channels to physical destinations and external middleware. The Binder SBI provides extension points for custom implementations, allowing you to connect to any messaging system. Each Binder implementation includes configuration classes and discovery strategies, making it easy to plug in new brokers as needed. Spring Cloud Stream automatically detects binders on the class path and configures them for use. When multiple binders are present, you can specify which binder to use for each channel, either globally or individually. This enables complex scenarios where different channels connect to different brokers, supporting advanced integration needs. If your application needs to connect to more than one broker of the same type, Spring Cloud Stream allows you to define multiple binder configurations with different environment settings. This is useful for scenarios like multi-tenant systems or hybrid cloud deployments, where different channels must connect to different broker instances. Spring Cloud Stream supports a wide range of configuration options for both bindings and binders. These options can be provided via application arguments, environment variables, or configuration files. This flexibility ensures that you can tailor your application's messaging behavior to fit any deployment environment or operational requirement. Binding properties control how channels connect to destinations, specify consumer groups, set content types, and more. These properties can be set globally or per channel, allowing for granular control over messaging behavior. Understanding and configuring these properties is essential for building robust, production-ready applications. Consumer and producer properties allow you to configure concurrency, partitioning, header modes, retry behavior, and more. These settings help optimize performance, reliability, and compatibility with different brokers. By tuning these properties, you can ensure that your application meets the demands of your specific use case. Spring Cloud Stream supports dynamically bound destinations, allowing applications to send messages to destinations determined at runtime. This is particularly useful for routing scenarios or when the set of destinations is not known in advance. The binderware channel resolver bean enables this dynamic behavior, providing flexibility for advanced messaging patterns. Spring Cloud Stream attaches a content type header to outbound messages, enabling automatic type conversion for inbound and outbound channels. The framework supports common conversions like JSON to POJO, byte arrays, and plain text. This ensures interoperability between different applications and systems, regardless of their native data formats. Beyond built-in conversions, Spring Cloud Stream allows you to register custom message converters. By implementing the message converter interface, you can handle proprietary formats or integrate with legacy systems. This extensibility ensures that your application can communicate with any external system, no matter how specialized the data format. Spring Cloud Stream supports schema-based message converters with out-of-the-box support for Apache Avro. The framework provides tools for schema registration, resolution, and evolution, ensuring compatibility as your domain models change over time. This is essential for maintaining robust, forward-compatible messaging systems in evolving environments. Spring Cloud Stream makes it easy to build pipelines of microservices that communicate via shared destinations. By correlating input and output bindings, you can create multi-application workflows where data flows seamlessly from one service to another. This pattern is fundamental to event-driven architectures and enables powerful data processing pipelines. Partitioning is configured by setting properties like partition key expression and partition count on output bindings, and partitioned, instance index, and instance count on input bindings. This ensures that data is distributed and processed efficiently across multiple application instances, supporting high throughput and parallel processing scenarios. Spring Cloud Stream provides a test support binder for testing applications without connecting to a real messaging system. This allows you to simulate message flows, assert on sent and received messages, and ensure your application logic works as expected. Testing support is essential for building reliable, maintainable microservices. Spring Cloud Stream includes health indicators for binders and a metrics emitter module. Health indicators help monitor the status of your messaging infrastructure, while the metrics emitter allows you to export application metrics to a named channel. These features enhance observability and operational insight, supporting proactive maintenance and troubleshooting. Spring Cloud Stream Samples repository provides practical examples for various use cases. To get started, you can use the Spring Initializer to create a new project, add the necessary dependencies, and implement simple source and sync applications. Running these samples helps you quickly understand the framework's capabilities and best practices. Spring Cloud Stream applications can be deployed on Cloud Foundry, leveraging environment variables for configuration. This enables seamless integration with cloud services and simplifies deployment in enterprise environments. The framework's flexibility ensures compatibility with various cloud platforms and deployment models. Spring Cloud Stream provides a dedicated binder for Apache Kafka, enabling seamless integration with Kafka topics and consumer groups. The Kafka binder maps destinations to Kafka topics and supports partitioning, error handling, and advanced configuration options. Adding the Kafka binder to your project is as simple as including the appropriate Maven dependency, making it easy to leverage Kafka's scalability and reliability in your application.